Welcome to episode 6 of the design series, creating a custom computer case for a NAS with SOLIDWORKS xDesign. In this series, we're transforming standard PC components into a fully functional, network-attached storage with a custom designed case. If you've missed any of the previous episodes, don't worry, you'll find the links in the description below to catch up. In the last episode, we reinforced the bottom panels and created secure supports for the motherboard. In this episode, we're tackling the back panels. These are essential as they'll hold the fans and accessories like the power button, switch, and plugs. To get started, I'll insert all the components we need into the assembly: power plug, a power button, and 2 fans. The setup is straightforward. One fan will cool the CPU, memory, and solid-state drives. The other will ensure proper airflow for the hard drives. Let's position the fans at the back of the case. First, I measure the available space to place the bottom fan right in the middle. For reference, I use the box I defined earlier as the computer's internal space. Now here's where things get tricky. You might already guess this isn't the ideal approach. The box I used isn't aligned with the planar face we need for the back panels. Yet I went ahead and positioned all the components on this incorrect plane. A solid start, right? Once I position bottom fan horizontally, I understand I need to update fan mates. Now everything is aligned correctly and I can finalize the bottom fan positioning with a distance mate. One great feature of xDesign is the ability to input equations directly. This simplifies calculations and ensures the fan is perfectly centered. Next, I position the second fan and the accessories. It's crucial to leave enough room behind each component to accommodate cables. This is where 3D design really proves its value, allowing me to visualize and verify the available space. While I'm at it, I update the mates for the power button and plug, aligning them with the correct face. This ensures everything is properly connected to the back panel rather than the main structure. With the components in place, I create the back panel using a 2mm extrusion. I position it with a coincident mate and add 2 distance mates to allow for clearance during assembly. Next, I update the mating plane for the accessories, linking them to the back panel instead of the main structure. This small adjustment ensures a more realistic and logical design. As always, I add chamfers and filets to refine the edges. Now it's time to create the mounting holes for the accessories. In the sketch, I round the dimension values. Precision isn't critical here since the placement was already approximate. I double check for any potential collisions with components behind the panel and adjust as needed. To finalize the positioning of the accessories, I use concentric mates. My process is simple. I slightly move each component to reveal any remaining degrees of freedom, then apply the necessary mates to lock everything in place. This method is quick, efficient, and ensures accurate results. To position the mounting holes for the upper fan, I use a rectangular sketch. This approach makes it easier to adjust values later if needed. Next, I create venting holes for the fans because, let's be honest, without proper ventilation, the fan is just for show. I also ensure enough material is left on the panel to keep it sturdy. I start by sketching a boundary circle based on the fan's outer dimension. Inside this circle, I add smaller circles to define the venting holes. Each circle is extruded individually to maintain flexibility. Once the initial setup is complete, I create a pattern, experimenting with different values for each repetition. After some testing, I settle on adding 6 additional holes per repetition, using the central hole as the reference for the circular pattern. The result is exactly what I envisioned. Next, I address the network plug. Using measurements from the motherboard, I create a rectangular cutout to accommodate the plug. You might be wondering why I chose this particular network port over the other one on the motherboard. Honestly, I should have wondered the same. After correcting some dimensions because I was slightly off, I notice another potential issue. The plug is deeper than the panel, which could make connecting the cable tricky. To fix this, I add guiding walls around the plug using thin extrusions. I carefully measure the distance between the panel and the plug and add clearance to avoid assembly issues. These walls will ensure the cable connects easily despite the depth. Now on to the bottom panel. I measure the dimensions of the existing holes and add them without external references, as the fan positions are fixed, avoiding unnecessary complexity. I reuse the top panel's design as it already has useful features. I remove unnecessary accessory holes and clearance for the network plug, then repurpose the vent structure. By tweaking just a few dimensions in the earlier rectangle sketch, the new venting structure is ready in just a few clicks. To secure the bottom panel, after I place it on planar recess, I locate it on a hole and add a parallel mate. Simple yet effective. No need to overcomplicate things. Next, I adjust the venting holes for the bottom fan. After reviewing the overall fan size, I realized that adding one more row of holes should suffice. I slightly increase the hole diameter and use sketch relations instead of dimensions to make the setup more robust. With equal spacing and equal size circles, only 2 dimensions define the entire pattern. I create the new hole, apply a cut, and generate a pattern with 6 more instances. For testing, I increase it to 30 instances, and it looks great. Finally, I finish with a chamfer on the fan mounting holes, and the bottom panel is ready. Before wrapping up, I tweak the top panel mounting holes to accommodate the larger than expected fan screws. A chamfer is added to finalize the panel. Now both panels are fully defined. It's printing time. First the bottom panel, then the top one. With the parts printed, it's time to assemble them. I start with the power switch, carefully avoiding tools to prevent damaging the plastic. Next are the fan screws, which require a screwdriver. Then I install the power plug and ensure the power cable is properly routed before securing the panels. Finally, I install the hard drive drawers, ensuring minimal cable management to keep everything accessible and correctly plugged in. This wraps up today's episode. In the next episode, we'll tackle the front and side panels and reveal why I've been hinting at Star Wars throughout this series. If you don't get it yet, don't worry, I'll explain everything. If you're feeling inspired to create your own designs and bring them to life with a 3D printer, check out the SOLIDWORKS for Makers website to subscribe to xDesign at an incredibly affordable annual price. Thanks for watching and see you in the next episode.